Welcome. We are going to talk a little bit about probability today. And the definition of probability is looking at the expected, that's the key word, expected frequency of one event, and you're going to focus on one event for all of the events. And the probability comes, you get more of an accurate result the more times you do it. So if I was flipping a coin, I'd flip it hundreds of times, and most of the times you expect half the times heads, half the times tails. If I flip it 5 or 10 times, I might not get half the times head, half the times tails. So this is a large sampling. So we're going to go through a few little different problems, and we're going to use this particular formula. And again, if you notice, it says expected right here. We're going to focus on the one event for the total number of events. So let's look at this problem right here that has our coin. Okay, so if we flip a coin, P is my event, and I want to know how many times do I get heads. Well, there are two sides to a coin, so heads is the one event I'm focusing on. And the total number of events, since there is a heads and a tails, that's 2 events. Half the time I expect to get heads, and if I was looking at tails, half the times I would expect to get tails, or 50%. Let's look at another example. So now we're going to use the same formula, and this time we're going to look at dice. Okay, so one dice. There are 6 sides to a dice. Since there are 6 sides, that's my total number of events. And I want to know how many times will I roll and get the number 2. Now, you would be tempted to write a 2 over 6, but I'm only looking for the one event, the number 2. And the number 2 only shows up on a 6-sided dice one time. So you got to be careful about that. So 1/6 of the time I expect, when I roll the dice, I expect to get a 2. Or if I need to change that, it could be a decimal, it could be 0 point, and it's actually 1/6 infinity, so it's a 1/7, or it could be 17% of the time I would expect to roll a 2. Now let's look at a deck of cards. So there are 52 cards in a deck, and the total number of events would therefore be 52. And if I want to know how many times will I get an ace, well, you might be tempted just to put a 1 there. There are actually 4 different aces for the different suits. So there's heart, diamonds, clubs, and spades. So there are 4 of that one event, 4 aces. So it could be the fraction 4 over 52. If I ask you to display your answer in a decimal, you would come over to the calculator and do 4 divided by 52. And then you would get, let's go out to the nearest hundredth, so that would be 0.8. And then if I ask for a percentage, then to multiply that by 100, and then you would get, or 8%. So 8% of the time, I would draw an ace out of a complete deck. Okay? So let's go ahead and look at some genetic problems following the same type of formula. On this one, we're going to be looking at dominant and recessive traits, and we want to know how many times a particular trait will be exhibited. If I read my problem, I'll see that the dominant trait appears 450 times, and the recessive trait appears, for the green color, 122 times. But I want to know the probability of the recessive trait appearing. That's my focus. With all the information given, I see that the recessive trait appears 122 times. So that is my P, or my one event. So that's 122. Now, the total number of events, most people, very common mistake, they will go ahead and put the second number underneath and go ahead and divide it out. But that's for the dominant trait. I want the total event. So to do that, I actually have to add those together, dominant recessive traits, to get my total events. So that would be 572. So then to divide that out, I'm going to first go as a decimal, and then I'll do that as a percent. So 122 divided by 572 and go to the nearest hundredths. So I'll get 21. So I will get the recessive trait 0.21 or 21% of the time. Okay, I could also do the dominant trait, in which case if I asked how many times the dominant trait would appear, it'd be 450 over 572. Let's look at our last problem. This one, trait occurs 450 times. I'm not sure if it's dominant or recessive. It does not indicate that. And it says a total of 1,800 individuals. So there's nothing I have to add, subtract, or anything. They just give me the numbers. So my one trait is 450 times. My total events is 1,800. So to calculate that, it would be 450 divided by 1,800. So 0.25 or 25% of the time this trait will be exhibited. So hopefully that clarifies on how to calculate probability. Just be very careful when you're looking at the total number of events, and also what event are you looking for. So like when I try to trick you right here on the ace or right here. Okay, so if you have any questions, just let me know.